Euclid's 43rd proposition says that in a parallelogram, complementary parallelograms are equal to each other. So first of all, we have to understand what are complementary parallelograms. Let's draw a diagonal AC, and on this AC, let's mark a point. Doesn't matter where, anywhere, except on A itself and C itself. So somewhere in between. Now, keeping this K as a point of interest, draw a parallel to AD, which means it is also going to be parallel to BC. Okay, so let's draw that point. This line intersects CD and AB. So let's mark those points as well, E and F. Similarly, let's draw a line parallel through K, parallel to AB and CD. And this line intersects AD and BC. So let's mark those points of intersection, HG. So here, if you notice, in a parallelogram ABCD, we have drawn a diagonal AC. So this diagonal AC passes through two parallelograms, AEKH and KGCF. Now, complementary parallelograms are the other two parallelograms that are left. So complementary parallelograms are EBGK and HKFD. Now the proposition says that this parallelogram is going to be equal to this parallelogram. Let's see how we can prove this. Now in parallelogram ABCD, this diagonal AC cuts the parallelogram into two equal parts. That is triangle ABC and triangle ADC. Remember, we are interested in this parallelogram. So what can we do to this triangle ABC to get this parallelogram? We have to cut out this triangle AEK and KGC. Remember, this triangle AEK is equal to AKH. Why? Because again, this diagonal for this parallelogram cuts the parallelogram into two equal parts. Similarly, this diagonal for this parallelogram cuts it into two equal parts. So triangles AEK and AHK, they both are equal to each other. Similarly, triangle KGC is equal to CFK. It would be more interesting to say KFC. Okay, so these two triangles are equal, these two triangles are equal. So what we'll do is we will take this triangle ABC and subtract AEK and KGC. If we subtract these two from this triangle, what are we left with? We are left with this parallelogram EBGK. Similarly, from triangle ADC, we subtract AHK and KFC. So we are left with this. Now remember, this triangle is equal to this triangle. ABC is equal to ADC. From that we are subtracting equal parts and equal parts. So which means what? That this parallelogram is equal to this parallelogram. So we have proved that the complementary parallelograms EBGK and HKFD are equal to each other. So that is proposition 43. Again, let me remind you, there is a link to a PDF book which describes all the 48 propositions of Euclid's book 1 of Elements. That's it for now.